I love your introduction, Farish, so go for it. We're live. Farish is going to introduce us to Ruby Monday.
Sorry, no camera view this week. My office is a disaster. Welcome to Ruby Monday, November 2nd edition, as we meet weekly to discuss our Ruby on Rails project. We do it as a group project. We focus like we are a Rails development team. Everybody has assignments. We go through issues, and we share our code weekly. If you're not part of the project, you're always welcome to join and watch. Also, if you have a personal project that you like to share code and you're part of the group, you're more than welcome to. Let's get started.
That is an awesome intro. It's going to need some edits, though. I'm sorry to break it down to you, but because now we're also doing the code challenges, the weekly code challenges. So we got to add that into the mix. You haven't been around for that, have you?
No, I was working in Auburn, California the last 2 weeks. You contacted me last week. I was driving that 8-hour drive back. And then once I get my office set up, I have a new blue microphone, the Yeti.
Oh, nice.
And you can for recording and other stuff now.
That's awesome, man. It's good to hear you doing a bunch of those things. Are you still recording your videos?
No, I've been so busy. This is my busiest time of the year, but I'm gonna start trying to cut back down on the Code Academy a little bit. Because it was actually interfering with my work. By the way, for those who are new to the group, I'm an advisor at Code Academy. They're having a Beta Pro program where they give you a mentor to work with, or basically through a chat system if you're stuck, you need help with your code. But it was just too much with my regular business.
Yep. So thanks for bringing us up to date with you, Farish. So let me kind of give everyone, because we have a ton of new people, what some of the latest things that we've been doing here in Ruby Monday now. So what we've been doing is kind of bringing up the Ruby skills up and doing it in a way that the whole community can participate by doing it in code challenges. So these are the same code challenges that you can do in JavaScript, you can do them in Python, you can do them pretty much in any of the languages that we have a night for. And it's pretty cool to see how everyone solves it. I think Diana was here for the last one, and Jesus definitely was here. So let me give you an example of that. This is the first one we did. I'm going to post it in the chat room right now. And let's see. Does everyone have that? So the challenge is trying to figure out how to get this out. We're doing it in 2-week sprints, and then you can share the code. Now the goal is to now post your solutions in the discourse and kind of compare notes. So one thing that's been interesting is, at least to get everyone going, is talking about every new challenge as it comes. And probably, I don't think you had a chance to talk about this challenge last week, right, Jesus? Because there was not too many people on.
No, we didn't talk much.
That's fine. So let me ask you, from the ones, and it's okay, mostly everyone here wasn't here for this challenge, which is fine. We're going to talk about the challenge right after that everyone here can participate on now. It was pretty fun. But just to kind of get an idea, Diana, were you able to work on any of this, on the first one at all? I know we were struggling a little bit and at least got you off the ground.
Yeah, I gave it some thought, but I unfortunately did not. So I'm ready to start a new one today.
That's fine, that's fine. And I know Jesus solved it like 3 different ways.
Yeah, of course.
Jesus, were you able to solve it?
Yeah.
I knew you would. You want to talk a little bit about your solution? That'd be great to see, and kind of it gives everyone an idea of what we're going to do for this week and the process of that.
Okay, where do you want me to start?
Well, let's start by, let me share the actual challenge, and then once I share what that was, then maybe you can start and share what your solution was for that. So let me do this. So this is the link that I pasted up. This was the challenge from 2 weeks ago, and the challenge was to pretty much build a poker hand where it's transcribed as follows. So here's the different cards and how you can identify each of the hands. So the challenge was down here. Write a program that takes a poker hand consisting of 5 cards and determine which type of hand it is. So by getting the 5 cards that are coded in this style, so 3 of diamond, 9 of hearts, ace of diamonds, 8 of clubs, etc., etc., you get a sample of 5, and then you have to figure out whether it's a straight flush, 4 of a kind, full house, etc., etc., etc. So that's the initial challenge. The stretch goal would be to determine if any of the cards are duplicated. So for example, a deck of cards has only 52 unique cards. So one way to tell if there's been tampering involved is that there's duplicates of a card. And then the other stretch goal was to return the hand from the series that has the highest value. So this was the first one. I know that a lot of people here weren't here for that one, but it's kind of neat to see how Jesus worked through this. So now you can go ahead, Jesus, start sharing some of your code.
Okay. Do you want me to start with the end result?
Sure. Let's see how it all works and then kind of walk us through what you did.
Okay. Can you see my screen?
I can.
Okay, so I made this script which was not required, but it used the code I had to write for the challenge.
Got it.
So this method, GenCards, generates all the possible cards in the deck. So there is 52, right?
Correct.
So this generates 52 cards, one of each. Then this generates a card using the sample method. And then I'll solve 20 times. There is some background noise.
That's no problem. We can still hear you fine.
Okay. So 20 times I create a new hand. Then I evaluate the hand with my poker engine and save the result.
Mm-hmm.
And then I print the result and the original hand, the input. So I'm going to run this so you can see what it looks like.
Yeah, please do.
So on the right, can you see the right panel?
Yeah.
So this is the output of the program. So it says the type of the hand that my program found, and then on the right it says the actual hand. So for example, this is a pair because we have 2 aces, pair and her. This is a 2 pair because we have 2 5s and 2 4s.
Yep.
So what my program is doing is re-adding the hand and analyze it to find what type it is. So the type is this. I'm going to run it again, so we get a new input. This is randomly generated.
And you're just doing 20 times arbitrarily, right?
Yes.
Okay.
It's 20 random hands.
Correct.
So I run it again, and we get nothing to pair. So we can see that pairs are very common. So let's run it a couple times. Let's see if we see a 3 pair or a straight. Here we can see, we get a 3 of a kind and a straight. Nothing, 3 of a kind. So you can see how this works, right?
Right. So before you move on, were you going to cover something else here? Just I don't want you to disappear on another page before, because I got questions.
No, go ahead with the questions.
Okay. So and anyone else, feel free to ask questions. Just speak up or put a comment on the chat, on the group chat that you have a question, and we can go over it. So I don't know everyone's Ruby experience. So let's just start off with some of the basics. Uh, does the group know what the %W is doing on line 5 and line 6?
I'm not sure what that is.
Okay. Anyone else? And then feel free to ask. I mean, it's really, that's what we're here for, to learn. So go for it, Jesus. I know what you're thinking. So.
And the %W creates an array. It's the same as in this here. So this equivalent to this. See? So this line 7 and line 9 are the same right here.
So it's just a shorter, cleaner way
Yes.
of writing it.
Yes. So they do the same thing. Here it's the same. So this is J. Okay, so it's much faster and cleaner to do it like this than having to have the double quotes.
That works only with single character string. I mean, with something where you wouldn't have spaces, right?
No, you have a space, no, it won't work.
Exactly. Okay.
Because
yeah,
it will be different elements.
Yeah, it would separate it out.
Yes, this will be one, and this will be another separate, different.
Got it. Very cool. Okay, so that's that. The other thing that I hadn't seen, I kind of figured out what it does just by kind of reading the code here, but maybe let me ask someone else.
Yes,
on line 19,
19.
you see puts, then you have the result variable, and then you
Yes.
have the ljust20. I kind of figured out just by looking at it, but anyone want to take a crack at what that is? I haven't used it before. It's just, I saw it right here. It caught my attention. Brittany, have you seen that?
I have not seen it.
You want to take a crack at maybe what it's doing?
Let's see.
Or go ahead and Brandon, I mean, pretty much it's open to anyone. Sorry to pick on you, Brittany.
No, it's okay.
I just thought you were the one that was unmuted, so I'm like, all right, Brittany's unmuted.
Well, because he kept yelling at me about being muted, so I like unmuted.
All right, so anyone else want to take a guess at what that's doing? Just kind of look at the code and look at the output that's there.
It looks like it's pushing everything to the left, or left justifying.
There
Yes.
you go. There you go. Cool. So we were along the same lines. So
Yeah. So ljust is left justify, and the number is the amount of space, and there is also r just, which is right justify. So that's how I'll get this column-like output.
and that way you have a nice clean output when you're doing that.
Yeah. So if I take this out, now look at the output, what a mess. See? See the difference?
Yeah, I see the difference. Yeah, it caught my attention because I saw everything was so clean and lined up, and I was looking at your put statement. I'm like, okay, wait a minute, there's something else going on there. Yeah, I like that. Okay,
Yeah.
so very cool. Anyone else have questions on something, on what Jesus did here? So we've got a couple methods. We have the flat map. We have two things, right? We have a map and then a flat map.
Yes. So it's combined. It's like doing map and then say flat at the end. So it's map, something, and then flatten. It's the same thing.
Got it. Any questions on those two methods, on what they do, map and flat map? No? Okay. And again, don't be shy about asking. Yeah, we haven't used everything here. All right, so let's see what else you got going here.
Okay.
Oh, sorry, Diana. So not sure what the flat method is.
Okay, I can show you. So let me go into Pray. So the flat method flattens an array, which means if you have a nested array, so this is an array, okay? And this is a nested array. So a nested array is one array inside another array. So let's say we want to take out the nested array and just have this. So we want this instead of this. So the way you can do this is using flatten. So we do this, and this is the result. The flatten simple takes away the nesting and takes the elements outside. So it takes the 1 outside and it takes the 2 outside. If we have a 3 or a 4, it will also take the 2, 3, and 4 outside. So the result will be 1, 2, 3, 4 without the nesting. So that's what flatten does.
Does that make sense, Diana? Very
Yeah, it does. Thanks.
Yeah, and I love, like I think we talked about it last time. Whenever you're learning a new method, that's my favorite thing to do. What Jesus just did. Go in your console, and then just start using it. Play with it, see what it does, see what you think the outcome is, and then what it does. And then yeah, go ahead. You got a bunch of questions, Jesus. The dot map method.
Did I also see? Yeah, okay, I can explain that map. So you know .each, right? So we have like one each and puts n. Sorry, I'm missing the parentheses.
Do you need the dot each?
1 second.
There you go.
No, like this. No, yes. Now I got it right. Syntax. Okay, so dot each is simple. We go over each element. In this case, we have a range. So we go from 1 to 10, and we do something with it, and something we do is puts it. So we can do anything we want. But let's say we want to double the number. So instead of printing the number, we want it double. So 2 times the number. So one way we can do that is inside the block, we can say times 2. But what if we want to save the result? So here is where map comes in. We can say map instead of each. And now what we get back will be an array with, if we take this, now what we get back is an array of the results instead of getting just the results printed.
Would you mind doing like an array equals and then the just so they can see what the new array would look like?
Right.
So instead of the P, do like an array.
Yes. Okay. I can do that. So
there you go. So now A is your new array. Did that make sense, Alexander?
Let me do this in ERB because I have printing in Pride. So it's more clear what's going on. Oh, I have it in ERB too.
Here, hold on. Let's see. I think I have just straight IRB.
Oh, I have it in.
Oh, you got it? Good.
In Windows. Here, can you see that?
Yeah.
Okay. So that's the difference. So if we say each, it will return the same element instead of the returning the result. With say map, it returns the result. So that's the difference.
There you go. So let's just start with the dot map. So does what the dot map do make sense now, Alexandra? Okay, cool. So now when would you use it? So let me give you an example. I can have, like, let's say a list of 1,000 phone numbers, but they don't have the right formatting. For example, let's say I needed to do some for my work, right? I need to do SMSing. I do a lot of messaging. And let's just, for example, say that the API that I'm using requires a very specific way of formatting that number. So maybe my list, as I have it, the numbers are like 2222222. Let's just say that. But my formatting for the API that I'm using requires it to be a +1 2222222. So I can take that list of phone numbers, do a dot map, and then inside that, do some kind of formatting to it. So maybe it's, let's see. This is just a very simple example, but that makes sense. And then the result would be a new array with all the phone numbers formatted correctly. Does that make sense? Very cool. And then I know Jesus is doing something else there.
Yes,
Go for it.
I'm going to show you another example. Capitalize. So let's say I have a names array, and all the names are in lowercase, and I want to have the names starting with uppercase. Okay, I want to capitalize them. So using map is used to change every element of an array. So each is just doing a calculation or something with the array, not changing it. If you want to change the array, you use map. So in this case, I want to change my names and capitalize them. So I say names equal names.map, and then inside the block, I say name.capitalize. And this gives me the array change with the capitalized names. Yes, yes, as I would, what I can change to each. So if I do, I have to go back because it's already changed. Now it's the original array, and now if I use each, you can see it stays the same. It doesn't change if I use it. Can you see that? So with each, you can't change the array. It's a mistake I have seen a few times when that you want to change the array, but you do each. So you want to change the array, you say map. All you have to do is change the each for a map, and then it change the array. Okay.
So what you're doing, Alexandra, is the each. It's kind of like if you were just calling a put statement. So let me do this. Give me a second. You see my editor here. So let's say we have an x equals 5. If we do x plus 6, we're going to get 11, but that 11 went nowhere. It's not stored anywhere. But now, if we do x equals x plus 6, now it's stored again, right? So each is kind of like doing just a put statement. It's going to calculate it, but it's not going to be saved anywhere. But when you're doing a map, what that map is doing, it is saving those results into a new array as it iterates to it. And it's just, a lot of times it's useful to have that information. As you start building more things and sorting through data, you'll see that it's a very useful method to have in the bank.
There is also a map bank method which changes the original array.
There you go. Very cool. Thanks, Jesus. Thanks for going into detail with that. So let's go ahead and let's see the rest of it.
Okay. So where we at? Okay, I'll show you the script that produce random output. So I will run it one more time so you can remember what it does. Then let me see how. Do you want me to show the test or?
Yeah, please. I think the tests are awesome.
Okay. So I have 22 tests, which are passing, of course.
Or
we will have a problem if they were not passing. So most of my tests are in the Poker Engine, but let me start with the card. So the card is the basic object I have in my program, and the card its job is have the value and the suite of the card. It's a pretty simple class. So it parses the card and then it converts the letter numbers to an absolute value, so I can compare it, because comparing a string with a number doesn't work very well. So
okay, hold on. Let's go back a little bit.
Where card?
Yeah, card.
Okay.
Yeah, you got a bunch of stuff going on there that I'm asking questions about. Okay, so scroll up. I think, was it in the test or where I saw some regex somewhere.
Yep.
Yeah, I knew I saw some. Okay. So does the group have you used regex before? Or, let's see, or regex, however you want to call it. I don't know what the right way is. Regular expressions, pretty much.
Yeah.
So regular expressions are an amazing thing, and there's also something that kind of messes with my brain a little bit. but it's such a useful thing. It's kind of like its own mini language within another language, because you can use regular expressions in Ruby and pretty much everywhere. Lately, I actually used regular expressions in a grep command.
Nice.
And which I had never done before, so that was pretty cool. And there we go. Thank you. Rubular is a perfect thing, the perfect tool to do that. So do you want to? I know, Jesus, we're going to make you explain everything today. You want to kind of go a little bit into that regex you have right there?
Okay. 1 second. I have a blog post on regular expressions.
Oh, nice.
Which is, I think, is good, and I will link it.
Yeah, please do.
So you can read that after to get a better idea. So you remember we discussed this 2 weeks ago when we started with this project for parsing the card. So we were taking a split because someone said chop, I think, something like that. So if the card is 5 of diamonds, so we can split it, and I get the 2 parts, okay? But I ran into a problem with 10. So the 10 is a bit tricky, and it made me change the parsing. But,
yeah.
But here is a thing. if I could have spent 2 hours, 3 hours thinking the possible ways to parse the cards, but I would have wasted my time if I did that. So, but I did the simple thing that works. That's always a good thing to start with, doing the simple thing that works. Then when you run into problems, then you know what the problem is, and then you can fix it instead of wasting time trying to find the possibilities beforehand. So we can see the problem is that with 10, I get 3 elements.
Yep.
And this is a problem because in my initialize method, I'm only using the 2 first one. So if I do this, what happens is that my suite will be 0 instead of the let me set the unequals. So the suite will be invalid, will be incorrect, and number is also invalid. It's 1 when number is 10.
Yeah.
So when I run into this problem, I treat a few things and I thought that a regular expression will be best. So I'm using the match method, which tries to match one string against a regular expression. And here I have a constant because I could have this right here and it will be the same. But I think we can agree that this is better because this reads card match card instead of card match. So everyone agrees that it is better or not?
I agree.
Okay.
I
So
saw some nods, so don't worry. They're all muted, but they agree.
Okay, so that's why I did this. So I like using constants when it makes the code more clear. So what this regular expression does is look for, it has 2 parts. The first part is this one, and let me copy it here. This is the number part. So of course, I miss the slashes, which else this is a regular expression. So I got a syntax error because this is not valid Ruby. So I have to add forward slashes to tell it this is a regular expression.
Mm-hmm.
Okay. So the regular expression size fine from, is the font size good or can everyone see this?
I can see it fine. I don't know. Does anyone need it to be bigger, or it's fine? Maybe make it a couple notches bigger just in case.
Okay, let me see. 16.
All right, that should be good. Here.
Okay. Okay, so this from the way you read a regular expression, you can, if you're not very familiar, you can start ignoring the symbols and all. You read the things you can start, the numbers, the letters. So you can see this arrange, this is from 0 to 9. So this is the same as 1, 2, 3, 4, 5, 6, 7, and but I can just say 0 to 9 and it's the same. Okay.
All right.
And then we have the G, Q, the king, and the ace. So all this is saying is find one of these. So either find a number from 0 to 9 or find a G or a Q, a K or an A. Find one of those. And if you find that, then return it to me. Since these are the only valid numbers these are the only valid numbers in poker. So that works. Then the second part is this one here, which are the suites. So this is the S is spades, I think, hearts, clubs, and diamonds.
Mm-hmm. Question real quick. So the 0 through 9, it would return both the 1 and the 0, right? For your tens?
Yes. So 3 to 1 is 0, 1, 2, 3, everything, all the numbers.
Right. So, but it would return the 2 digits, in other words. It's going to go digit by digit.
Yes. It returns two digits because I have this plus here. This plus symbol says look for one or more. So in theory, this will be valid.
Mm-hmm.
But I expect the input to already be valid cards, so I am trusting that the input is valid. So that's why I can do it this way.
Yep, got
that. So yeah, this will give me the correct parsing of the cards. Any more questions about that?
No, I think that's mainly, but that's on my end. Anyone else from the group have a question on that? On regular expressions, on what that's doing there? How's it making sense, Brandon? I know you're on week 4 right now, Firehose. I don't think we had touched regular expressions by that time.
No, not too many, but I've seen them in the past, though.
All right, very cool. Anyone else? Every now and then I just pick on you, so don't think it's for anything. All right, how about you, Jacob?
Yeah, just listening in. This is pretty foreign to me, but good stuff.
All right, yeah, it's good. The resource that someone posted in the link earlier, Rugular, if you're finding this interesting, and regular expressions really do come in very, very useful in so many cases, it's good to play with that site and just kind of figure out how it works and what finds what. It's very neat.
I've definitely run into them on the front end.
Yeah. Very cool. All right, thank you, Jesus. Keep going.
Okay. So so the test for that is the first two ones. It compares the card number and it compares the card suite. So you can say I have 10. Before 10 I had like 6, I think. So that's why I didn't find this earlier.
You didn't find that error.
Yeah, so instead of creating a new test, I just change an old test to cover the problem.
Yeah.
Then I have a test for absolute value, which is what I explained before, to be able to compare the letters with the numbers. So that will be 2 through 10. And I have this compared to cards, which I don't think I am actually using. This was yes. I should check if I'm actually using that. Maybe delete it. I thought it will be useful. Maybe I'm using. I can't remember. I did this like 2 weeks ago. So, so that's card. Then after doing card, I have the hand. The hand has 5 cards, and it has just one test because it's very simple what it's doing. It just reads in a hand an input string. This is the input string. And the test says it can turn an input string into an array of cards. Very simple. So I check for the card size to be 5, and I check that the first card, the value for the first card is 3, which is this one. So let's see the hand class. We can see here we have an example of map.
There you go.
So I use map a lot. It's like the Ruby method I use the most because it's super useful. So in this class hand, we can see that I require the card. We require relative. Then I have two attributes, the cards and the original, which is the input string, in case I want to use it later. So this is used in the script that I saw before, this one. Okay. Then I have my initialize method. This takes the input string, which is again this right here. And then it saves it without changing it as original. And then it does this, which is the parsing of the cards. So this says for each hand, we can split it. We can split because this is a it's very simple string.
Yeah.
And the separator by default is the space, so we don't have to say. Some people I think that do this, and you don't have to do this because it's the default.
It's a default already.
Yes, the default. So that's what that does. So at this point, before the map, what we have is an array of the strings, 5 strings, which everything is a card.
Yeah.
Then I use map to convert this array of string into card objects. So I say for each card, create a new card object and pass in the card. Very simple. So cards, it's the resulting array from map.
So you have an array of card objects by the time you're done with it.
Yes, that's correct. And the rest of the methods are like you could say utility methods or support methods for the rest of the program, which we will see now. So these are very simple. I'm using map again to get the card numbers, and then I'm using this to get the card values, and the values, remember, is this. And then I'm using inspect and redefine override the inspect to return the original. So this allows me to have better test errors, because when I test files with hand, it will show like the object ID, and if I do this, it will show the actual hand input, which is more useful. So it will show this right here.
Yeah, got it. So we got two questions here. Go ahead.
Yeah.
Sorry. Go ahead. So one is Diana. So what ended up happening to 10 and being able to split it, or is that what our regular expression was for? Yeah. So that's what the regular expression did back in the card object. So that regular expression, that will split either 1 through pretty much 10, whatever we have right there, or whether it starts with a jack, queen, king, or ace. So you could have like a jack of diamonds, and so we want to be able to split that.
Okay, cool. Thanks.
So that took care of that. And then we have another question. Line 13 and 18, are those shortcuts? And that is in the class, in the hand class.
Yes, there's a shortcut to this form of the map. So let me expand it so you can see. So this is the same as saying, and that. So the two are the same thing.
All right, Brittany, which one was that? Sorry about that. So before I go on, so did that make sense on what those shortcuts were? All right, cool.
So if you want to learn more about this, search for symbol toproc. Search for this on Google or on the Ruby documentation, so you can learn more about this. And if you want a curiosity, this syntax was originated in Rails. Later on, it was added to Ruby core because it is very, very useful.
Nice. Do you know when in Ruby it got added?
I think, yes, 1.9.
Oh, nice. Very cool. And I'm really glad that you kind of told us what to search for, because a lot of times that's where you get stuck. You know, you don't even know what something is called. So then I start going on Google Ruby, and then I just put the and and the colon, and nothing comes up.
That will not work very well.
Exactly. So thanks for putting that. All right. And then the other thing was Brittany. So which part was it? Do you remember around where?
I think the screen that we have on now, the method inspect at original, I think I heard him say if that fails, if hand fails or something, like, I can't remember. I'm sorry. The last one on this. No,
I think she's talking about your inspect method that you have.
Yes.
Okay. This one.
Thank you.
Okay. So you know that object has an inspect method. So for example, I can say this string and say dot inspect, and this gives me a representation of this object. So you have another object, a custom one like class, let's say ABC, and I create a new one, abc.new. You can see this right here. This is the inspect output from my object. You can see that it doesn't tell you much. It's just an internal ID for Ruby, so you can do a lot. You can do much with that. But if you say def inspect, we can say anything here. This is an ABC object, and now we create a new one. You can see what happened now. We say .inspect. What happens is we get this. So this could be anything like the instance variables or something else that is more useful than this.
So, Brittany, what he's doing is he's overriding a default method with his method, because he's saying if I needed to debug this, if he looks at what he has right under line 66, if he looks at that, it's not sorry, in your terminal.
Okay.
If he looks at right under line 66, that's not going to tell him much. If he's debugging and he sees 0xC3, it's not really going to help him too much. But by overriding his inspect method to show him the original array, now he can see where things started going wrong if he's inspecting that. So exactly. It's just a simple way of overriding a default Ruby method on an object. Does that help a little? Very cool. Thanks, Jesus.
No problem. Okay, any other questions or something?
Yeah, I have one. How'd you get so good?
Practice a lot, read a
There
lot.
you go. That's a good answer. Practice a lot. All right, keep going, man. Thank you.
Okay, so that covers the hand class, and after the hand class, I did the poker engine, which is where the magic happens.
I
Like
love
some
the name of that,
people,
by the way, Poker Engine. Nice.
yes. So let's see the specs for this. The specs can be a little scary. You look it like this, but the key here is where there are two parts. This like the setup where I set up different hand types. So for example, here is my test pair. Here is a 2 pair, a triple, a 4 of a kind. So this lets me compare that my output is correct. Okay, so and I group this. So some people do this and put everything together, but I like to separate things in blocks that make more sense, for me at least. So for example, we can agree that the 3 of a kind and 4 of a kind form the same group, or the straights are their own group, or nothing is something separate from the rest. So that's why I did that. And space is free. So Ruby doesn't care if you have a lot. So that's that. Then the tests. So this is where most of the tests are. So I have one test, maybe so I have one test for every hand type. So I started this with the simple possible hand in poker, which is the pair and nothing. So these are the two first tests. So the first one says it can find one pair of cards with the same number. So this means if you're not familiar with poker, that two cards must have the same number. So the number is the first part of the card. So
Yeah, so that would be like a 3 of diamonds and a 3 of clubs right there.
yes. So that's why I'm using here the pair. You can see this pair here. So the why I have this is Poker Engine is a module, and then it has a check pair method, and I pass the hand in, and then it checks that it returns true, which means it's correct. It's correctly a pair. It found that it's a pair. So if it is a pair, returns true. If it isn't, it returns false. Then the next test I have test for nothing. So if I pass in a hand that doesn't have any valid combination of cards, then it's nothing. There is nothing there. So I check for that. So we don't get false positive. And the other tests are the same thing, but testing different types. And the last test, this where it is a bit different. I test the evaluate method. So the evaluate method takes any hand and returns the type. So instead of returning true or false, it just tells directly this 3 of a kind, this straight flush.
Got it.
And I identify those with symbols. So let's see the evaluate method. This is it. this is the method. So I start with the priority of the how I explain this. So let me start with the end. So if there is nothing, then it will just return nothing. So this means that all of these conditions return false. Okay. So the first check, it calls the straight flush method. Then it calls the flush, full house, straight, 4 of a kind, 3 of a kind. So I have these are methods. I have this on the right.
So if I'm following you correctly, the reason you have them in that specific order is because it'll stop checking if it returns
Yes.
true from top to bottom. So for example, if you started first with a pair, but you had 2 pairs and you put the pair first, then you would match with pair even though you would probably have 2 pairs there.
Yes, exactly.
So the way you're doing it is pretty much from most complex to least complex.
Yes, that's it.
Very good.
So it keeps checking. If it's not this one, then it checks the next one. And let's say it's a pair, then it will return pair, and we know it's a pair. If it doesn't match anything, it means it's not a valid hand, and it just returns the nothing symbol.
Yeah.
Okay. Then we have the methods, the implementation for all of this, which is down here. So let's start with, I like these ones because they're very similar. So I have check 2 pair, 3 of a kind, and 4 of a kind. So I of these rely on another method, which is count card values, and count card values is here. And what this does, what this does is count the cards. So here is map again. So I told you that I use map a lot. So here is map again. So let's start from the top of the method because this method is pretty important from what I'm doing here. So first of all, I start with the total, which creates an empty hash. Okay. And I have the numbers, which is just the ID numbers in the hand. So this is this method right here. Okay. So this at this point I have an array with the numbers. So that looks something like this. 3, 5. You get the idea. It's just an array of the
values of each part.
Yes. So next thing is let me delete this. Delete. So now I map this to the count. So what I'm doing is called the count. The key here is the count method. The count method goes over the array and counts the numbers. So let me demonstrate in Pry. So we have a 1, 1, 3, 4, 5, 1, and we say a.count1. It tells us how many ones there are. So there are 3 ones. To here doesn't matter the order. It just have to be there. So we tell it how many 3s there are. 1. How many 9s? 0. So that's what it's doing. Okay.
Everyone follow that count method. That's a very simple method, but it's really cool to have that one there.
Yeah.
Very cool. Keep going.
Okay, so that's what I'm doing here. I'm calling count on on every on every number. So I know how many threes I have. I know how many um, uh, I know how many fours. So I know how many of each card I have. So I can say there is three of this card number. So there is three kings, or there is three whatever. So then I return the values, the results from the counting, and then in check to pair I can use this to say how many cards are two times. If there are exactly two, then that means we have two pairs.
Mm-hmm.
Then three of a kind. If there are three of the same kind, exactly three, then we have a three of a kind. And the same with the others. So that's I think it's a very elegant way of calculating how many there are.
Yeah, I like that full house method.
Mm-hmm.
That's pretty clever.
Here I reuse my three of a kind, and then this method. So
Couldn't have you used the pair one right there?
yes, but my pair is different.
Okay.
And my pair is here. It could be the same, but I think this is faster. I will have to benchmark it.
Got it. No worries.
In other words, I did what you shouldn't do, premature optimization. No, actually, I didn't think of it as an optimization. This is the first method I wrote. So when I wrote check pair, I didn't have any of this. I didn't have my count card values. I didn't have three of a kind. So what I explained before, though the simple thing that works. So when you are programming, you don't have to do super complicated things. You don't have to do super complex. Complex is bad. You
Totally
couldn't.
agree.
Yes, you can do something simple and it works. You should do that. So that's why I did here. Okay, so that's my methods. I have flush. So flush is very simple too. I get the suite, the first suite, and then I check with the all method that all the cards have the same suite. So that's what a flush is. At least according to Wikipedia. I don't play poker, but I use Wikipedia. So if this rule is wrong, the fact.
No,
So
you're
yeah,
good.
yeah. So that's that. Then the most complicated maybe can be simplified a bit, but this checks for sequential numbers, which is a strike. So a strike is a hand which have a sequence of numbers. So for example, 10, 9, 8, 7, 6 will be a strike.
No, why are you using the duplicate right there?
Okay, I had to use the. I think I can get rid of it. No, I know because I'm doing shift. So shift changed the array, the original array. So if I don't do dupe, I run into a book that so you remember the evaluate method, right?
Mm-hmm.
So this hand is the same hand for all the methods.
Yeah.
So if I change the hand, so the shift change the hand, the other methods will get a different hand.
Yeah, they're gonna get the tainted one. Okay.
Yeah, so let me give you one example. If I do shift, I get the first, which is 1, but then A has changed.
Exactly.
It's no longer the original. So that's why I have to do dupe. Dupe, what does is another copy. So it gives you as like a clone. You can think of it like a clone of your original object. So when I change, it doesn't affect my original object. That's why I have to do that.
Very
So
cool.
I have been experimenting with a white jet right of the dupe, and you can do that with a numerator. I have another branch. You can, if you want to see it, or we can see that later when I put this on GitHub. Okay, let me go back to the header.
Yeah.
So I take the values and get a clone of that. Then I sort the numbers. And here is a special case. According to Wikipedia, the A's can work both as the 1 and as the last one. So in my case, I have 14. Yes, 14. So this could be either this. So in this case, this is in reality like 1, 2, 3, 4, 5. Or it can also be, I think it's 10 G and A. So according to Wikipedia, there's 2 are valid strings. So that's why I have a special case.
Yeah.
So if it's the special case, I just return true, and we are done. I don't have to do anything else. So if it doesn't match, if there is no match, whatever.
Yeah, you said it right.
Then I take the last number. Well, it's not the last, it's a bit confusing because in fact it's the first.
It's the first, yeah.
But I say last for a reason, because I'm comparing the last in the loop, in this loop here. I'm comparing the last number I check with the next one. That's why it's last. So maybe I should make a note thing that can I improve that. If you have suggestions. The problem if I call this first, then inside her it's not first. So you can, I'm using her. So I can say first her. But so it's a bit of like the rabbit and the whatever and the egg or whatever.
I get it. I know. I see. I would have probably done like temp last or something just so I know it's temporary. But
okay, so on I have this the first one. Then I go over the rest of the numbers, and I compare the last with -1. So I do -1 because this is a sequence, which means there are one after the other, and the next one has to be one less.
yeah.
So this is a valid one. But if we had 10, 5, it's no longer valid. So as soon as I think that it's not valid, I return false.
Yeah.
Now, when I reach the end of checking this, then it means nothing was invalid, nothing returned false, so I can return true.
Yep.
So that's
You can do that because right at the beginning you sorted the numbers first, so now you're just comparing the order of it.
Mm-hmm.
Okay.
Yeah, and then the last method is a strike flush, which is almost the same idea, but in addition to the number, I have to check the suite. So this the same as this, but I also check that the suite is the same. So if the suite is not the same, I can return false also.
Yeah.
So that's all the code.
That's awesome, man. That is very cool. So there was a lot to take in. Any questions, at least on a couple of the methods? I know maybe if you didn't follow exactly what everything was, that's fine because there was a lot. Are you going to put this up on GitHub where people can check it out?
Yes, I can do that.
Awesome. So that'd be cool to share that. Any questions on any of the methods? Maybe if you didn't follow what everything was doing, but anything you saw in particular that caught your attention? How'd you feel, Brittany? Any questions?
Like a lot of questions.
Go for it. Ask one. Pick one and ask it.
I wouldn't even know where to start.
I'll give you some time. If you come up with one, go for it, okay?
Thank you.
What about you, Diana? Got something that you want to throw? Any method in there that you're like,
No, I'm
I
excited.
like how you look all comfy, by the way.
Thanks. My brain hurts. Mine is blown right now. I need to lay down. Yeah, I do like the methods that he used, map, flat, and also what you guys said about like just using it in the pry and just getting to know it and repeat it. So that's something I'm definitely taking away from this.
Awesome. Very cool. And Hoagie, I don't know if I'm saying your name right, but any questions on your end? Silence says no. John, man, so much easier. Thank you. All right, Jacob, what you got going?
Nothing, man. Just absorbing this Ruby stuff. Just trying to take it all in.
Yeah. So these are meant to be tough challenges. I mean, Jesus did this like in, his sleep or something because he's good. But the point is, and we were talking about this when we started the challenge initially 2 weeks ago. Once you see the whole thing, you're like, whoa, how do you figure everything out? But you really don't. You figure out one thing at a time. Remember, Jesus, what we were trying to figure out first was just how to parse the card.
Mm-hmm.
That's it. We weren't doing anything else but just trying to figure out how to parse a card. So, and now you need some water. Go for it. But so, it seems overwhelming when you're thinking, oh man, I need to solve everything. But you're really solving one piece at a time. Right? It's just one little piece. Like the first thing is, okay, how do I get these two numbers to mean a card? Once you figure out how to parse it, then okay, how do I assign it a value, et cetera, et cetera. So you keep going from that, and you'll start seeing how everything kind of glues together. Hey Mo, I know you came in towards the end of it. How's everything going with you?
Everything's going good.
Yeah. Did you do this challenge also?
I didn't have the time to do it, but I was definitely thinking about it and knowing that Jesus is going through the entire engine. Cool stuff, Jesus, by the way.
Yeah, it was amazing. He did really good. That was a really cool challenge. Very cool. So if you come up with any other questions, Brittany, go ahead. So we have a good question, Brittany. So we have a coding challenge every 2 weeks. So that way it gives us time to kind of have a discussion. Then we can see what the work is through it. Any questions midway as you're working towards it, we can work on it together. And then kind of like a review. This is just the second challenge. Well, that was the first challenge. We're about to talk about the second challenge right now. And it's a new format. We're trying it out, and it seems to be working out because it gives us actual code to talk about right away. And one of the good things about talking like the new challenges while we're on the call still is it kind of gives people, when you see a big challenge, you could paralyze to it, I guess. That happens to me all the time. I just see the bigger problem, like, oh, what do I do here? So being able to start it together kind of gives us a chance to talk a little bit about it and get some ideas going. So let me do that at this time then. Let me share with you all this link. I'm going to share my screen as well. And I think this is a fun one. Have you taken a look at this one, Mo?
Not yet.
Okay, so this is a zombie alert. That's the new challenge we have going for these 2 weeks. So Jamal does an awesome job of writing these for us, and he's very creative with them. So here's the story. Okay, the Human Protection League is on high alert and is preparing to defend against a zombie attack. Reports giving them reason to believe that the rest of us then may become an imminent and dangerous threat to humanity for the next 2 weeks, or in the next 2 weeks. So let's see how this is going right here. In this challenge, we're going to get to play with some zombies. They carry the zombie plate, which turns ordinary humans into more zombies. So let's see what this involves as far as coding. They thrive in enclosed spaces where escape is difficult, if not impossible. Create a grid to simulate an enclosed space, 15 by 15. Seems like a good size, but if you want to make it larger or smaller, that is fine too. Humans and zombies will move around in this space, moving one space in any direction for each turn, but make sure that they do not escape the edges of the room. Have your program start with a single zombie, and 10 humans. Humans and zombies will take turns moving until all the humans have become zombies. Here's what the room might look like on turn 1. Notice that there's a single zombie and many humans. Zombie plague is highly contagious. If a zombie and a human come into contact, the human will become a zombie. Soon the room will be overrun by zombies, or with zombies. Have your program start with a single zombie and 10 humans. Humans and zombies will take turns moving until all of the humans become zombies. Woo! All right, we're going into like Walking Dead Ruby Monday edition. So, what do you all think of this challenge? Any initial thoughts? Jacob, I see the eyes rolling. You're like, oh man, what did I get myself into? So let's start with the basics. What's the first thing that we need to create in this challenge? Anyone want to take a crack at it? What is the first thing? Even if you're not doing it with code, just what's the first thing we're trying to do? The box, nice, a grid. What does that sound like to us? Does it sound like anything to you, Diana, that you can think of already?
The only thing I'm thinking about right now is like HTML and CSS, and that's not part of this. So no.
But that's a fair shot, because I think you're thinking of it as a visual thing.
I think so, yeah.
There you go. Anyone, and we'll talk about it. Anyone have any ideas as far as code? Oh man, Brandon dropped off. He would have been perfect for this question just because I know the Firehose curriculum. But oh, nice one. There you go. A 2D array. That's exactly what I was thinking. Does that make sense on what he's talking about, a 2D array? So pretty much what we're talking about, let me do this really quick. Let me share my screen here. And feel free to jump in ideas. This doesn't mean this is what it has to be. So if we were going to create, let's say instead of 15 by 15, because I don't want to do 15, if we were going to do a 3 by 3, then we can do an array or a 2D array, so an array inside an array. And I'm just going to represent it with zeros. So that's 1, 2, so does that make sense? Is that what you were thinking, One? Very cool. So pretty much we would just have this, but with 15. So that's the start. Now how can we reference each one of these points?
We can do that by the index.
Perfect. So that way we know exactly what each one. So we're referencing, we want to change the, let's see, in the second array, actually the second one, the first one, the first item in that one. One of them for that one. How we look at our array? We have that. We can do that. So does that give us at least a little bit of a start when we're talking about that 15-15?
Yes.
Very good. Alexander, does that make sense to you? Cool. Brittany, how are you doing there?
So the array that you have now represents a board that would be 3 by 3.
Exactly. So it's what one called a 2D array, and it's just pretty much arrays inside of an array. So a regular array would just be 1, 2, 3, but instead of including a single item, we're just putting an array inside. So inside of our main array, it's 2 items, and each one of those objects is also an array. So right there we'd have a 2 by 3. Very cool. So that's a start, right? I mean, at least we figured out how we can figure out what our 15 by 15 is. Now, I don't know, anyone else want to take a shot at next steps?
I have a question with one of the directions.
Sure.
It says if a zombie and a human come in contact, the human will become a zombie. Would that be like when they're next to each other, if they occupy the same space on the board?
That's a good question. Huh. Not sure. What do you all think? I don't think there's a... You know what? There was a section that I was asking about where we can ask clarifying questions on this. Let me see if it's up. I don't know if it's this one. Nope. I'll ask, but we can make our own call on it right now, I guess, since we don't have any further direction on it. What do you think it means by contact? When they occupy the same space, or when they're right next to each other?
Well, yeah, when they're adjacent to each other.
So you're thinking adjacent. I'm thinking adjacent also, because then it would be kind of hard to have 2 of them. Then we would lose a human, right?
Yeah.
So I'm thinking it's Walking Dead style. It's adjacent. There you go. Jesus says contact. Yeah, adjacent. All right. So when they're adjacent to each other, does that help, Brittany? All right. Any other questions on that? Any other thoughts on what, like, some next steps that you think you could take with this?
I still don't understand what does it mean to not make the zombie reach the edge of the room.
So the edge of the room. So for example, you're gonna have to determine on this. I'm assuming this is I haven't thought about this longer than you all have. I really just saw this right before starting the hangout. But for example, when you're moving your zombie, right, you're gonna have to determine what's a valid array move. So if you don't determine the limits of your array, then you could end up extending your array and making it larger.
Yes, that's true.
Does that make sense?
Yes.
Yeah, let me see if I can. So I think that's what we mean by that. That you have to make sure that you're staying within the constraints of your 15 by 15 box, if that's what you choose to do, or whatever size you're going to do. Making sure that all your moves. Oh, good question. Does that include the diagonal contact as well? I would think that it does, because it's still adjacent contact. But what about the rest of you, though?
Technically speaking, from a square point of view, a diagonal contact would be very much no contact, because it's just the tip of the edge. A straight square contact would be when your right, left, above or below would make contact. So I can understand the confusion. I'm still confused myself, but
No, yeah, it's a very valid confusion. Let's see. Any thoughts on that? What do you all think? How do you want to challenge this for next week? Any contact, diagonal included, or just a straight contact, top, bottom, left, right? Are you back, Jesus? What do you think?
Yes, yes, I am back. Fingers adjacent contact on the bottom, top, and right and left.
Okay, that works. So top, bottom, right, and left. Any other questions? And if Jesus gets really quiet right now, it's because he's already written half the test for this, okay? Just so you all know. All right.
so basically this is a game of time because we're constraining everything in the game to be inside this box, and we start with a zombie who has the what do you call that?
The virus.
Yeah, he's infectious to everyone else. So it's a game of time, basically. Eventually, everybody will turn into a zombie, right?
Exactly.
I see.
So what kind of loop do you think this will be then? Because like you said, eventually everyone will be in a zombie, turn into a zombie. So what type of loop will this be?
I'm guessing a while, maybe?
That's what I'm thinking too. It sounds like a while loop to me. So while we still have a valid human in somewhere in our array, then we continue looping.
Uh-huh.
Right? I mean, that's what it sounds like. I think we have some agreeers.
And is this totally randomized, or is there intelligence in the game, in zombies chasing humans and humans escaping zombies?
So I think, based on what I'm reading right here, let's see, it's randomized in the sense that if you see here, it says humans and zombies will take turns moving.
Uh-huh.
But it doesn't tell us like they're trying to run away from zombies or anything. It just says they're taking turns moving. So I think right now it's more of a challenge of finding all the zombies and humans and the logic around whether they're adjacent, the logic to limit them to their 15 by 15. But it doesn't sound like there's any intelligence as far as the movements. I think it's just random zombie-human movements. If they're adjacent, they turn into zombies.
So
Go ahead, Brittany.
So a person opens this up in their command line and it just starts randomly moving humans and zombies. I guess I'm trying to figure out, like, is this a game where people like do the movement, like move here, or is it just like random?
I think, and this is just me thinking, okay? Don't take this as the law of the land. I'm thinking, yeah, it's probably a game where we're gonna, output this to the terminal, and we're probably gonna get like 15 or however X moves until we're doing that. So we're gonna be seeing this running and kind of regenerating our grid every time, and we see the new moves and how the zombies are eating everyone up.
Okay.
But that's my take on it. I mean, if you want to do it a different way, I think go for it. Let's see. Any other questions on this initial one? So let's take a look at the stretch goals then. So the stretch goals this is the basic challenge. Now the stretch goals is, if you figured it out, you still got some time and you want to kind of push it a little bit further. So here's some of the stretch goals. Humans may be able to escape a zombie attack. If a zombie comes close to a human, the human can attempt to move away from it.
Yeah, so this is applying some kind of intelligence.
Exactly. Now you're applying, so I'm guessing by close it cannot be adjacent because by that time it's too late.
Yes.
So within a range, if you're close, then you're going to try to extend that distance. Eventually you won't have anywhere else to run, but make sense?
Yes.
Now stretch goal 2. There you go, back to your intelligence. Zombies are suspected to be able to smell the brains of their victims. If a zombie is close enough to a human to smell its brain, it could pursue them. Okay, so now we have a zombie pursuit. Nice. We'll have to talk to Jamal about these challenges. But very cool. Okay, so yeah, that's interesting actually. Now it's gonna lock into a target. Ah, okay, right. That just makes it a little bit different now, at least in my brain. Very cool. And this part that's why I saved it until the end, because this is the part that usually the Hangout gets very, very quiet because everyone's just trying to wrap their heads around what the challenge is and how to even get started. So if you're quiet right now, don't worry, I understand. This is the part where it's hard for me to continue talking also, because I'm trying to figure this out also. What do y'all think about this challenge? Good challenge? Bad challenge?
Cool challenge.
There you go.
Yeah. The coolest part is the intelligence part.
I think so too. That's gonna be very interesting. Jesus, what you got?
Working on it.
I know you're working on it. I know. I have no doubts about that. Very cool. So how about we do this? Because I think, does anyone have any questions or need any initial tips on how to get started? Any initial questions? Now, this doesn't have to be a solo challenge. So, for example, I know there's a couple of you that are just getting started and you might not feel up for the whole challenge. That's fine. The Ruby Monday channel on Slack is there to talk about this. So you don't have to go at it alone. Let's say you want to pair up with someone and kind of work through it with them, or you want to pair up with someone who might be a little bit more experienced than you are. Just start talking and chatting about it in the Slack channel. Say, hey, I need some help to get started, and just take a crack at it. Even if you don't get through the whole challenge, just the fact that you figure some of the things out is going to teach you a lot about how to break these bigger problems down and trying to work through them. So don't get intimidated by it. Take as much of a crack at it as you can, and then talk about it in the Slack channel, and hopefully we can all help each other out and work through it piece by piece. Very cool. So I think that everyone's brain right now just got like, what am I gonna do next? So what we'll do is we'll take a break now. We'll end the call. Let you.
I have the word.
Go for it, Jesus. What you got?
I have the word printed.
You have the what?
The word, the game board.
Oh, you have the game board. Let me see the game board. There you go. You get your initial hint from Jesus.
But I don't want you to cheat and see my code. Don't look.
Okay, don't. Hide your code, Jesus. Hide your code.
Now you can look.
There you go. You see the board?
It's not perfect yet, but
you have a board. So Brittany, was it Brittany or Diana? I don't remember now. Sorry about it. About how I think Diana, right? You were thinking of HTML, CSS. Well, here's a way to put it in just the command line.
Oh, cool. I'll steal that from Jesus.
Okay, all you gotta do is, hey, Jesus, what do you think of pairing up on this?
Thank you.
Very cool, Jesus. Thank you. And he hit his code pretty quickly, so I wasn't able to snap it yet. So sorry, can't share it with you guys. All right. Well, thanks everyone for joining. We're gonna call it a night. I think everyone's mind's been blown already. But thanks a bunch, Jesus. Thank you so much for sharing your solution to the last challenge. That was awesome, man. And please feel free to ask for help on the Ruby Monday channel. That's what it's there for. And aside from that, again, thank you for joining. Hope you enjoyed it. Catch everyone out next week. Bye.
Bye.
Bye.